We are going to continue our discussion of unit conversions, and so this chapter we're going to kind of use what we had done in the previous section in chapters 1A and 1B as a platform to see some more interesting unit conversions. And so we really want to now be able to express metric and imperial measurements in the other system of measurement. So that is to say, if we are working with metric units, we want to be able to express them in imperial and vice versa. And to get there, we really want to be able to, still be very comfortable in working with dimensional analysis within metric units. We're going to see units of surface and volume, fractional units, and then actually get to that imperial and English conversions. And then at the end, we are actually going to discuss some more chemistry applications with grams, atoms, and moles. Okay, and you can see the suggested resources for this section of the course because it is not in our standard textbook. Okay, and so just a reminder, last time in one of the videos we saw this or these examples. So if you need to pause the video and go back and review dimensional analysis from those videos, I encourage you to do so, because that we're going to take this as a skill that we are already comfortable with for this video and the videos to come. So again, pause the video, review these as needed. But for right now, we want to work on units of surface and volume. And so remember that we've seen exponents, and so an exponent is indicating the number of copies of each unit. And so we need to make sure that when we're going through dimensional analysis that we convert each copy. Okay, so we'll do a few examples and then I'll have you pause the video and try some on your own. So first thing is, we're given this example of 0.03 times 10 millimeters squared, 0.003 millimeters squared, and we want to convert it to nanometers squared. So first thing is, I like working in scientific notation, so I'm going to write this as 3 times 10 to the 3 minus third millimeters square. Okay, and so now maybe you can work with it, and I'm going to show you kind of two ways of doing this in the two examples, and you can choose which way you want to proceed. If you want, the first way is to say, well, this is really saying we have 3 times 10 to the minus 3 millimeters, millimeters times millimeters. And let's try that again. Okay, and so now if you can imagine each of these with a denominator of 1, then we're set up to do dimensional analysis and convert each of those to our desired unit of nanometers. So that is to say, if I look at millimeters and nanometers, nanometers are certainly smaller than millimeters. So when I do that, I'm going to get 10 to the positive 6 there. Again, reference that log scale as needed. And so I would cancel this millimeters with the first one, but I still have kind of mixed units here. I have a millimeters and a nanometers. I need to convert the other one, so I'd repeat this again. 10 to the 6th nanometers. Okay, and then cancel, actually undo that, cancel the millimeters and that millimeters. Alright, so I'm left with 3 times 10 to the minus 3 as I multiply across times 10 to the 12th, again adding the powers of 10 nanometers square, or my final answer is 3 times 10 to the 9th nanometers squared. Okay, so this is a unit of surface. It's measuring kind of a length and a width, so that's why we have square units. Okay, now the next example, same sort of thing, but we are going to instead do a little bit different method that is a little bit more, that is quicker to do, but might be harder to understand. Okay, so again, micrometer squared to kilometer squared, okay, and it's already in scientific notation, so that's lovely. 3 times 10 to the 5th micrometers squared. And now I'm going to multiply by, okay, I'm going to focus on just converting micrometers to kilometers, my desired unit. Okay, let's focus on that first. Well, in 1 kilometer, there is 10 to the 9th. Okay, they are 9 units apart here. So there's 10 to the 9th micrometers in 1 kilometer. Again, look at the log scale as needed. And now, normally what I would do up here is do that twice, but, well, again, it's multiplication, so this is the same as doing it squared. Okay? And so, if I convert 1 unit, all I need to do is include an exponent of 2 on it to represent that multiplication twice. And so with this, the micrometer squared will cancel with that, but then we have to use laws of exponents, right? So 3 times 10 to the 5th, and then this is over 1, and then this is going to be over 10 to the 18th. Okay, again, raising exponents as needed. And then this will be kilometers squared. And then simplifying, we get 3 times 10 to the minus 13 kilometers squared. All right? All right, so next, so this is units of surface, and for volume, it's going to be the same sort of story. So I want you to pause the video and try these next two on your own. Okay, and so next you will see the answers here, and then we'll kind of briefly go through them. And here are the answers. So in the first one, I did it the long way out. I wrote out the 3 copies of centimeters and then converted each copy. Yes, it is more writing, but I find that students make less errors when they do this. So I encourage you to do that if you are kind of a little shaky and you might think you are prone to making an error with this stuff. But then, so you convert each copy of the centimeter to meter, putting the centimeters in the denominator, 10 squared centimeters per meter, and multiply across. And I simplified the powers of 10 as I went through, and got minus 3. The second one, same sort of process, but I did the shorter method. So 3.2 times 10 to the minus 5, that's what we started with, and then I had converted kilometers into nanometers, and there we go, and remembering the exponent of 3. Now, how did I get 31? Well, remember, distribute the exponent, right? So it would be 10 to the 36th, and then you take away 5 of those, so 10 to the 31. All right, so this is a video that kind of just summarizes how to convert units of surface and volume. I encourage you to maybe review these, try them on your own, check the answers again, just make sure that you're on the same page. And then next we're going to see these as we move forward in fractional units.